Hello students, today we are going to take up the topic physical and chemical properties of noble gases. So this topic is under group 18 P block elements plus 2 inorganic chemistry for CBSE, ICSE and state board exams. So let us start with a very good thought. Dreams is not what you see in sleep, is the thing which doesn't let you sleep. Dr. APJ Abdul Kalam. So we will come to know about general introduction and we will be able to explain about group 18 elements, electronic configuration, occurrence, trends in physical and chemical properties and their reactivity and uses of noble gases. So let us start group 18 noble gases. So these are coming under representative element and group is 18 comes under P block and they are called as noble because they rarely combine with other elements. Why? Because their octet is complete. Their reactivity is very low. Earlier it was named as inert gases, but now it is changed. It is known as noble gases. All are monoatomic. Helium, you are not finding He2. That's not possible. You are not finding Ne2. That's not possible. So they are known as rare gases because they are found in very small amount in the atmosphere. Radon is radioactive in nature. In 1962, it was found that these gases possess some reactivity to form compounds under certain conditions, particularly xenon, and therefore they are known as noble gases rather than inert gases. So let us start with electronic configuration. General electronic configuration of group 18 noble gases are NS2 and P6, and if you talk of helium, that is 1s2, 2s2, 2p, 1s2, sorry, and neon if you are talking of 1s2, 2s2, 2p6, and thereby if you are talking of argon, third period, krypton, fourth period, xenon, fifth period, and radon, sixth period. Okay, now let us discuss some physical properties. First, see the elements helium, neon, argon, krypton, xenon, radon. These are the elements of group 18 elements. Atomic number, you are clear that you are adding 8 here, you are adding 8 here, you are adding 18 and then 18, then 32. And now atomic mass is almost double of the atomic number. Electronic configuration is clear to you. Here filling of N1. Period 1, period 2, period 3, period 4, period 5, period 6. Similarly, down the group atomic radius increases and these are gases, therefore van der Waals radius is there. Ionization energy down the group decreases. So this 1037, 1170, this ionization energy is very less. So therefore it can lose electron to form number of compounds with fluorine or oxygen. Electron gain enthalpy is very meager. We can say there's no having any tendency to gain electron. That's known as electron gain enthalpy. And density, as you know that as you go down the mass is increasing, so the density is increasing down the group. Melting point, boiling point also, you know that forces are increasing down the group. Which forces? Van der Waals forces. And forces are increasing, so melting point, boiling point also increases. And the percentage availability in the atmosphere is 5.24 in case of helium, and that is argon is 1.82 times per minus 3, and krypton is found in very good amount, and so similarly radon is the least availability is there because of radioactive nature. Now ionization energy, as we discussed already, ionization energy of noble gas is very high because of completely filled orbitals. And that too decreases down the group because atomic size increases down the group. And therefore xenon will be having least ionization energy, so therefore it can form compounds like XeF4, XeF6, XeO2F2, XeF4. So this is the physical properties. The density is increasing down the group. Atomic radius is increasing, particularly van der Waals radius. Increase in the number of filled shell, yes. Melting point, boiling point increases. Potential increase in reactivity, yes. Xenon is more reactive than helium. So this is about the general physical properties of group 18. solubility and liquefaction. So these gases are poorly soluble in water, and therefore helium is used by the divers along with oxygen to prevent the condition of bands. And down the group solubility is increasing due to dipole-dipole interactions. And liquefaction means gas I want to change to liquid. I have to increase pressure and decrease temperature. But the which gas will be more easily liquefiable is xenon. Because down the group van der Waals forces increases, so ease of liquefaction will increase down the group. Next is about discovery of Neil Bartlett. So here in 1962, Neil Bartlett was doing the experiment of oxygen with the compound platinum hexafluoride, and he found that these two reactants combined together and the color compound, like orange color compound, is formed, red color. So then he concluded that if oxygen can lose electron, if molecular oxygen can lose electron, then similarly xenon also can lose electron. So then he was thinking that if oxygen can react with PTF6, then xenon also can react because they are having similar ionization energy. So then he tried with xenon and PTF6, platinum hexafluoride, and then he found the product. The product was formed XCPTF6, and that was the red color compound. So thereby the start of this discovery of xenon compounds. Okay, so although we are not able to find any compounds related to helium, neon, argon, only xenon is forming the compounds with oxygen, fluorine. Okay, yes. Next is about uses of noble gases. Noble gases, if you are talking of neon mainly used in discharge tubes, and fluorescent lamp which are used in advertising purpose. If you see in the market, there is the boards are there, signboards are there, in the shops outside there will be some boards are there which is display board is there. So that is meant that the gas is there, used as neon, advertisement purpose. Used in beacon lights. Beacon lights means the tower, very high tower is there near the seashore to give the direction to the ship. So that are known as beacon lights. So there it is used. It is filled in discharge tubes with the characteristic color. Discharge tube means television also. Previously the tube based television was coming, or monitor is coming, cathode ray tube. So that is discharge tubes. Following are the uses of argon gases. It's provide an inert atmosphere in high metallurgical process. You know that any metallurgical process, iron for example, you are doing purification, then it can be oxidized. To prevent the oxidation, we are using an inert atmosphere. So inert atmosphere is given by these gases like argon. It is used in laboratory to handle air sensitive substances. Okay, because the same thing that it prevents the contact with the air. And argon along with nitrogen is used as a gas filled electric lamp. This is because argon is more inert than nitrogen. Okay, you can see from here also in the tube lights. Then if you break that discharge tube lights, the old one coming in the market. So if you break that, then you will find the gas in that. So these are noble gases only. Okay, so what we have learned so far is group 18, general electron configuration NS2 and V6, and helium is completing the duplet, otherwise the octet is there in case of other noble gases. Radon is radioactive in nature, and it is the decay product of radium-226, and due to complete octet they are having less tendency to form compounds, but xenon can form compounds with fluorine or oxygen. The best characterized compounds are those of xenon with fluorine and oxygen under certain conditions. Argon is used to provide inert atmosphere. Helium is used in filling balloons for meteorological observation. Neon is used in discharge tube and fluorescent bulbs. So let us start discussing one or two questions. What inspired and Bartlett for carrying out the reaction between xenon and PTF6? This is very, very important question. So you can see that previously Neil Bartlett prepared oxygen PTF6 compound, then he reacted oxygen and PTF6, and then he thought that if oxygen can react with PTF6, then xenon also can react. Why? Because his logic was clear. So logic was because they are having both same ionization energy. So molecular oxygen O2 and xenon having same ionization energy. Therefore, we can say that that also will form compound. Then he tried that, and after trying he was able to redefine, he was able to explain that Xc can react with PTF6 to form the compound XcPTF6. Next is regarding to noble gases are having large atomic sizes as compared to group 17, 15. Why? Noble gases are inert in nature. They don't form molecules. They are in a monatomic state. So the atomic radii of the noble gases correspond to van der Waals radius. So van der Waals radius are larger than covalent radius. Therefore, noble gases have comparatively large atomic size. Next is noble gases have very low boiling point. Why? Yes, noble gases have been monatomic and no interatomic forces except weak dispersion forces or van der Waals forces. Therefore, they are liquefied at very low temperature and hence they have low boiling point. So, hopefully you might be knowing these answers. So, let us repeat the thought. Dreams is not what you see in sleep. It's the thing which does not let you sleep. Dr. APJ Abdul Kalam. Thank you.